Okay, so let's get started. Thanks so much for joining us for this new edition of our Behind the Scenes seminar series. I'm Severin Tussar. I'm at the University of Oxford. I'm doing this with Vatsa Kandeval, who is at the University of Exeter. And we are super excited about today. Thinking about interdisciplinarity, we're super happy to have Drazen Prelec join us. You are one of these people who just doesn't need any introduction, but I think, let me just say that you've worked on so many different topics at the intersection of cognitive science, thinking about neuroscience, behavioral econ, in a very wide range of things, on risk, time preferences, self-signaling, and also you have an anti-research agenda on Bayesian truth theorems. I'm thinking about individual and collective judgments. So what a great person to have on the seminar series, thinking about individual judgment of researchers about research projects. Thanks so much for taking the time to do this seminar with us.
Great. So so I'm going to present for about 15 minutes the paper that was published now 8 years ago, a solution to the single question crowd wisdom problem with two colleagues, Sebastian Sung, who was at MIT at the time, but has now moved to Princeton, and John McCoy, who was also at MIT, a PhD student in brain and cognitive sciences, who has also now moved to University of Pennsylvania, Wharton. And at the end, I may say a little bit more about the genesis and their roles and our collaboration and so on. But I will just focus on the paper now. So if you look at this is the paper. Let's see. Yeah. This is the paper and the abstract, and it actually got us the cover, which made us very happy. The cover is they called it the Unclouded View. It's a paper about aggregation of opinions and crowd wisdom and democratic voting in a certain extended sense. So I will start with the title, because if you look at the title, this is not the original version of the title. The title is a bunch of nouns. It has solution, a single question, crowd wisdom, and a problem. It's basically a string of nouns. And a colleague of mine who is German told me that you could actually convert that title to a single word in German, because in German allows you to actually put nouns together. So that, I don't know German, but that would be the title on top in German, okay? So, and these are my two collaborators, Sebastian Sung and John McCoy. So let me explain the title. I will start by talking about each of the words, each of the nouns in the title. Crowd wisdom. What is crowd wisdom? Crowd wisdom is starts with an observation that is straightforward and obvious, which is that a group of people has more information than any single individual. And therefore, in some sense, the decision of a group should be superior than decisions of individuals. And this goes back, this is the fundamental principle behind democratic voting, which goes back to the Greeks and earlier to groups. Anytime you have a group of people, the information in the group is larger than that in any single head. So many heads have more information than a single head. The question now becomes, how do you extract this information? This has a long history. So the history goes back thousands of years. In mathematical terms, one thing not here is the first theorem about crowd wisdom goes back to Condorcet, his jury theorem, which actually I want to maybe take Galton off the screen. The jury theorem by Condorcet says that essentially if you have, this is in the 18th century, late 18th century, says if you have a group of people that can vote yes or no on some claim, and each has a greater than 50% chance of being correct, then if you ask enough people, the majority opinion of the crowd, as the crowd gets bigger, is guaranteed to be sure. So this is a fundamental result behind democracy. If each person is correct above 50%, then a large crowd will be perfect. That's The other result, an empirical result, that goes back to early 20th century by Francis Galton, which actually is credited with the crowd wisdom method. Galton wanted to test whether majority opinion is empirically correct. And as his test, he went to a country fair in England, early 20th century, and asked people at the fair. At the fair, they were selling living animals who would then be slaughtered and their meat would be sold for profit. And the question was, how much meat would one animal deliver? And it was he wanted to see whether the average opinion of people looking at the animal would actually be able to assess the correct amount of meat that the animal would provide. And among the people looking at the animal, there are some who are experts, who are traders, who are in the market, and some are just tourists, visitors who are there just for the sunshine and the occasion. And he collected several hundred estimates, and he picked the median estimate. The median estimate is the one that has 50% higher, 50% lower. And he found that the median estimate was almost exactly correct. And he declared this as an empirical confirmation of democracy. And what makes the result interesting in a different way is that he was actually politically not a democratic, he did not like democracy. He was a very traditional Victorian. In the 19th century, democracy was not a given. There was an issue about whether you need to have some amount of money or some amount of education to participate in political elections. And so in some sort of, he said, sadly, I have to confess, in this case, democracy worked. That was his rule. So the democratic vote is one very robust, very ancient, and here empirically validated method of combining opinions. Now, we're going to test this method and we'll propose an alternative in the paper. What is a problem? We're going to look at, these are now problems in the paper itself. We're going to look at trivia questions to test different methods. One trivia question concerns whether a particular city is the capital, and these kinds of questions are used a lot in cognitive science and psychology and so on. The second is a question about aesthetic value, whether a particular painting is, what is the value of an artistic painting? And the third, and these are all from the paper itself, a third would be a medical diagnostic question, whether a particular lesion is malignant or not malignant. And this is the kind of issue where you might consult one doctor, you might consult two doctors, you might consult 5 doctors. So the question becomes, how do you combine their opinions if the doctors disagree? And in the artistic question, again, you have an issue that judges or evaluators or curators in museums might disagree about what the value of this is. So we need a method for reconciling this. When I say what's the importance of the single question, that if we look at where any particular method might be applied, we're looking at methods that can work with unique questions. So that means it's not like, which is a distinction relevant to the empirical examples here. In the empirical examples here, especially with artworks and lesions, you can imagine that there's hundreds of artworks, hundreds of lesions, and so you can track the accuracy of judges or use machine learning or something like that with a lot of data that will actually work. But we're using these questions basically just as tests of method. What we're really interested are in unique questions that are important, that would be very hard to find similar questions. You can establish some sort of a set of questions that you can assess the accuracy of individuals. So these are 5 examples. The first one is a difficult forecasting question. You can spin variations on this, like, for example, what is AI going to do in the next 5 years, in the next 10 years? The second one is a historical question. What is the actual source of the lab leak? We may never know. The third one is the counterfactual questions, which is what would have happened if some other policy had been adopted. And then the last two are questions that are debated in the disciplines, in the economics discipline, in the philosophy discipline. So the world is full of questions that are unique, that are going to be with us, and that will survive AI for some time. So these are the type of questions that we want the method to apply. But we're going to look at these methods to test it. So these types of questions are test questions for assessing whether methods work. These are the ultimate domain where we want any method to be applied. And finally, what is the solution? This is the basic idea in the paper. The basic idea is that we're going to ask people not just to give us their personal opinion, and in the simplest case, it's a personal vote, yes or no. We're also going to ask them to predict how other people will vote. And in the simplest case, we just ask them to estimate the percentage of yeses and the percentage of nos. And then there is a mathematical result in the paper that says that under certain ideal conditions, the true or the correct answer is not the answer that gets the most votes, it's the answer that gets more votes than predicted. That's the basic principle. And we've labeled this the surprisingly popular principle. So it's an answer that exceeds expectations. So, and this has a sort of a lot of mathematics underneath, but it can also be presented really without mathematics, and that's what the paper does. The paper, I don't think that does not have a single equation. It does have supplements, which has some mathematical statements and so on, but the paper itself has no equations in it. So I'm going to introduce it with, remember we have a trivia questions, we have art, and we have lesions. I'm not going to talk about lesions in the interest of time. I'm just going to discuss one example of a trivia question and then one example in the art domain. So trivia questions. So this is a paper and pencil survey. It's one of 7 studies. We have 7 different studies in the paper. It was a survey that was actually done in a classroom. And it contained 50 questions. Each question was for one of the US states. And for each state, the question was the same. The question always was, is the largest city the state capital? So going down the alphabetical list, Birmingham is the largest city by population in Alabama. The question is Birmingham the capital of Alabama? And each person answered either yes or no, or true or false, and then estimated the percent of that class that would estimate true. So this is the data that goes into the algorithm. Each person answers true, false, and gives a percentage. So it's a binary question and a number from 0 to 100%. So we'll look at the data for one particular state. But one thing that you might think of these questions as being repetitive and having no real variety. It turns out that's not true. There's a fair amount of variety in these types of questions, and there's versions of it that have been done in Europe for other purposes and so on. There are some questions, some states are easy and some states are hard, and that is interesting in itself. For example, the top 4 happen to be states where the largest city is not the capital. And it turns out that that's a hard problem for Philadelphia and Pennsylvania. It's an easy problem for Los Angeles and California. Most people, for some reason, know that Los Angeles is not the capital of California. But many people think Philadelphia is the capital of Pennsylvania. And it has to do with the history of the city, and it has to do with the fact that LA is known for films and so on and so forth. So there's a lot of these types of questions, even though the trivia questions, they ask people to consider all sorts of different information. That is the city prominent? Does it have a history? Do I remember something important politically happening in that city and so on? Is there another industry in New York? There's a finance industry, so New York everybody knows is not the capital of the state of New York, and so on. So let's look at some data, and the data will actually give us the basic principle. This is Philadelphia the capital of Pennsylvania? Yes or no? Turns out the correct answer is no, but in the US, reliably, most people think the answer is yes. And we see that around 2 to 1, these are the, this is the percent. I hope you can see my cursor. This is the percent of the people that say yes, percent of the people that say no. And they're incentivized, they're given a bonus for being accurate and so on. Then in the literature, there's been a lot of discussion, well, yes or no. We have here experts and non-experts. Why don't we ask people for their confidence? And so if you ask people for their confidence, they will give you an answer on a scale of 50 to 100, where 50 means I don't have a clue, 100 means I'm certain. And you see empirically here, there's really no difference in their confidences. And one of the contributions of our paper here is to derive that even people who are perfect Bayesians, their confidence is not a reliable indicator of, that is, people may be overconfident for psychological reasons, but people, even if people are not overconfident for psychological reasons, their level of their probabilities are not a reliable correlate of expertise. We can have a discussion about this if anybody's interested. And so now, if you remember, we asked them for that other question, which is the percent of the people that will answer true. And now we see this is now the percent of the people that will agree with their opinion. And they answer on a scale of 0 to 100. And so you see that people who say yes, almost all of them think that other people will agree with them. And people who say no think that most people will disagree with them. So we see essentially that this secondary question, whether other people will agree with you, is very discriminating because it differentiates between those that don't know the answer and those that do give different answers. And I'm sorry, I'm just going to have to just for a moment take a very quick, just a very quick. I'll be right back in 1 second. Okay, so this is the basic idea. The basic idea is in these graphs, the people who say, people who have the wrong answer, who have the correct answer, can anticipate that other people will disagree with them in this case. So now I'm at 523. I would need about 5. How strict do you want me to? There is a theorem behind this. The theorem is here expressed in the form of a logical syllogism. Essentially, the assumptions behind the theorem is that people can reason hypothetically. They can think about, on the hypothesis that Philadelphia is the capital, how many people would believe that? And the answer is, if Philadelphia is the capital, even if I'm not sure of that, in that hypothetical case, almost everybody should believe it. Why would anyone disbelieve it? On the hypothesis that Philadelphia is not the capital, it's quite possible that many people will not know that. So the principle here is that people have some sense of what the distribution of opinions will be on hypothesis 1 and hypothesis 2. They're basically roughly hypothesis testers. And if you accept this view, then you see that you essentially create a benchmark for what the percentage of yes votes should be for you to be confident that Philadelphia is the capital. That percentage should be high. If it turns out to be 50-50, you probably know that Philadelphia is not the capital, okay? because why would 50% of the people not think that? They must know something else. So that's the syllogism here. Now, I'd like to give you, and we can return to. I'd like to give you the second illustration, which is more substantive, and this is a test applying this principle to the domain of value in art. So we have had in the study 90 artworks. We recruited 20 professionals and 20 MIT students who claim that they've never taken an art course. So we had experts and novices. And we asked a bunch of different questions, but for each artwork, the key question that I'm going to address for the moment is a simple one. Is it worth more than 30,000 or less than 30,000? So essentially, we're converting a more complicated assessment of the market value, which we know, because we know the market value in each case. So they were, I should say, they were not told who the artist is, but they did know the technique, the size, and they knew it was 20th century. That was the frame. So they had to estimate whether it was worth more or less than 30,000 and what percentage of their peers, that is their art galleries or their novices would vote above or below 30,000. So to give you a sense of this is now part of the test. You can think about for 2-3 seconds, is either of these worth more than 30,000? And this is the answer here. If we had more time, I would ask you to vote, but since we don't, these are two different artists. These are market values at the time of the paper. Very, very difficult. Okay, data, and then we're done. We're going to track the performance of each individual using a logistic regression. So that means that you're going to see here on the x-axis the actual dollar value of paintings on a log scale from 75 to many millions. And on the y will be the probability for a particular individual that an artwork of a particular price is judged to be worth more than 30,000. So this would be an amazingly accurate person, because this person would treat all paintings under 30,000 would fall in the low category, and then at 30,000 there would be a crossover, and then for paintings above there would be a very high probability they would rank them. So these are logit estimates are based on 90 paintings per person, so they're very stable. This would be a person who knows nothing, and this would be a person who can discriminate, but is actually very much biased in making a judgment that something is not worth more than 30,000. So here's the data. On the left are professionals. Many of them have strong positive slopes. They know something, but there's a few that know nothing. So they are somehow in the industry without any knowledge. This is one, this is another one, another one. And at MIT, there's one person who's just amazingly good, even though they've never taken an art course, but the rest are basically flat. Now, suppose we have a committee of 20 people, and we use democratic voting. Is the painting worth a jury of 20 experts? So let's look at a jury of these art professionals. How well will the jury do if we use democratic voting? Each person counts one vote. And that will be given by the blue line. The blue line is the democratic vote of a jury of 20 experts. And you see that basically at 30,000, they are going to say it's not worth 30,000 for sure. It's extremely biased towards the low category, because the bias of each individual is basically multiplied over and over and over again. And that is what you can think of as an unwise crowd, that democratic voting amplifies individual biases and produces a super bias at the end. If you use the surprisingly popular principle, you're basically, this would be the performance curve of an algorithm that uses, compares votes to predicted votes, and it's basically unbiased. So that's it. That's my presentation. We had 7 studies. I think that's not important. Some states and so on. And I'll conclude just by taking a peek behind the scenes. We had to propose a cover art. They went with something else. The cover art was very political. Remember, this is 2016. Trump had won the election. We had someone like Napoleon and a group of people looking at Napoleon. There was one person looking at this painting, which was actually the Blue Rider, which was a piece of expressionist German art that was banned by Nazis and so on, but they didn't go this way, but they used it. Okay, so I took a lot of time, and thank you.
Thank you so much. That was great. So Vatsal is gonna share in the chat the link to the survey. So we're gonna try to forecast the behind the scenes of this project, and that's a very cool slide. I really enjoy, thinking about also these aspects that we can see, and I wouldn't have even thought about. And while you guys, if you wish, take the survey, we'll continue a bit the conversation with Drazen, because you've worked on this topic for quite a bit of time. And I've always wondered, and I'm going to be ask my selfish question, how did you stumble on this topic? Is there something that, kind of made you want to work in this area more? And did you anticipate that you would work that much in this area?
So I became interested in this general area as a student. In fact, somewhere transitioning between undergraduate and graduate. And it was always a strong interest, but it was never my, as I would put it, job making or job earning project. I was interested in perception, in sensation, psychophysics, some phenomenology and so on. I did experiments in psychoacoustics and so on, and I was interested in sort of subjective judgments in domains that are, for example, things like humor, things about wine perception, so on. And I remember it was always my advisors and the market, as it were, didn't really like this topic. I gave job talks where I would actually give 2 talks, and one would be something that would be basically in the behavioral economics space, and the other would be something like this. And this never, well, I shouldn't say never. My first job was at Harvard Business School in the managerial economics department, and it was a lunchtime job talk, and I actually brought a bottle of wine to that talk, and I said I'm going to demonstrate a method of judging the quality of wines and so on. I didn't have this method. I didn't have this at all. I was looking at other things. So this is certainly not, but I was interested in this sort of general area of how people learn to use language for subjective experience. What is truth in the domain of subjective experience? Is there a right answer to counterfactuals? So that was kind of always in the background, but it didn't pay the rent, as they say. So it's kind of it was a serious interest in terms of time, but behavioral economics was what paid the rent, basically.
It's great you ended up working on this anyway, eventually.
Yeah, you keep coming back to it, yeah.
exactly what you're interested in. Maximize the value of information for yourself as well. That is cool. In terms of collaborators, clearly on this project, you mentioned you had 2 collaborators, and you've collaborated with a broad range of people over the years across different disciplines. How do you think about collaborators in general?
So I think you need to have so there's lots of different things that go into collaborations. One thing is this kind of notion of the optimal distance, that the collaborator has to be different, but not too different in some ways. So my most enduring, long-standing collaboration has been with George Lowenstein, and that's an interesting one because I was a psychologist, PhD, but interested in uh, rationality, decision theory, mathematical models of game theory, and so on. And he was an economist who was basically very interested in psychology, in substantive psychology, experimentation, social psychology, and so on. So we're kind of trained against our natural interests in some ways. And that created a very good a mix because we could both understand each other very well, but had often different sense of what was really interesting or where to go. And then collaborations are really my collaborations are usually with very few people. So I tend to collaborate with a smaller number of people for extended periods of time over something, but that's just a style. Other people are great collaborators with many, many different teams and so on. But if you find someone that generally collaborations almost always improve the paper. It's just writing a paper solo is very, very difficult. Very difficult. And I've produced some of the papers that I'm most proud of are actually solo papers. But it's remarkable how what a distorted picture you get if you're just writing a paper by yourself. You really lose sense of what's you can, and then someone has to pull you back up because it's very hard to when you have two people, you just get a reality test, that something's not working. So I would say, but on this particular project, I really didn't have many collaborators. I worked with students here and there and so on, and RAs, but the collaborations now have started in connection with this particular project. And now I do have a long-standing collaboration with John McCoy, which is generating a series of papers. And that is one of those long, enduring collaborations, that is ongoing now, So that's that.
Amazing.
And John is also an interesting case because he is a PhD he got his PhD in brain and cognitive science, and that's how we joined the collaboration. But he has a separate PhD in mathematics, which is not that well known and doesn't really affect too much of what he does day to day, but it's very important. So that's again one of those optimal distance collaborations.
Yeah. Yeah, no, absolutely. And there's probably also something about personality that could be important. Some people might be more pessimistic about their work and asking to slow down and reflect more about things, and some more always, positive. Maybe we also need a combination of that. I'm not sure if this is something also that you've encountered within your.
Yes, that is true. In fact, it's interesting. I'm not going to mention the name, but there is a senior decision theorist who hasn't published very much, published very little, who asked me once, did I ever, or how often did I resend a rejected paper? And I said, well, I did. And he told me he's never resent a rejected paper. Okay. He's like basically pessimistic. And it's true. He managed to have a good career without, publishing certainly under 10 papers. Somehow it worked out. But he said, if it's rejected, I give it up, which is really not the way to go. So, but the other thing is the question of how quickly do you resubmit it? And if you're pessimistic, it's easy to wait a long, long time. And especially not this paper, but I had a different paper that I worked on for a long time that I sent to Psych Review when I was assistant professor, and it was rejected, and I never resubmitted it. And it was a long paper. It was a major paper on something called the information pump, and it still has some life online, the method, but it just never submitted it, which is a big mistake. So, and the referee comments are often very harsh. I think one of the referees called it adolescent or something like that. Okay, and it's like those few words just you know are a downer. But
yeah, makes it. Yeah, we have to toughen up. That's always the difficulty. Yeah. That's how are we doing on the survey? Shall we go over?
Yes, I think we can get started. So I'm gonna share my screen now. Okay. Let me go on presentation mode. All right. So why don't we take a couple of questions if it makes sense, and then you can comment on them. Does that sound good, Drazen?
sure, yeah, absolutely.
Okay. So the first question was, how many years do you think it took the researchers to go from conceiving the idea to getting it published? This is what everyone said, and you said 10 years. And then this one was about whether you've presented it at an external conference or seminar and how many times. And this is what everyone said. And you said more than 4 times. Why don't we actually take these first, and then we have some questions on
Okay.
the peer review process. So one question before you begin, and you can add this to your response, is like, how does this relate to your other projects? Is this below or above the median time that it takes for other projects?
Well, this one took a longer, but other projects are also quite long. So I think for this one, I said 10 years. I think no major, well, I would say only one major paper took less than 3 or 4 years. And the major papers took more than 5 years, for sure, all of them. Okay. Absolutely. And so when I say major, I'm looking at papers, 6 or 7 or 8 papers, that yeah, it's so 5 years is not bad, I would just say. It's kind of remarkable. There is one paper that was fairly quick. This is actually, it's related to this. It's on questionable research practices with George Lowenstein and Leslie John. And that was very timely. It had an audience waiting, so that went through. I think it was rejected at Science and then accepted at Psych Science. So that whole thing was under 5 years. I'm guessing probably 3 years or so. Yeah, but that's an exception.
All right. Should we go on to the next one? The next few on peer review, maybe.
Sure.
So how many journals do you think this paper was submitted to before being accepted? You said 2. And how many rounds of revision do you think the paper went through after receiving the first response? You said 3.
That actually is not. Well, that's a very. I can give different answers to that, but I think I think we sent led us to the editor more like 6, 7 times. It was really submitted a total of 6, 7 times. Yeah, I think.
Right.
Yeah.
Okay. And the last one in this category was about how many months it took to address the comments of the referees. And you said 6. Maybe we actually take all of these questions, and this might be a good time if you want to share your screen and share any of the reports or anything from the publication process if you want.
Sure. Since those questions were raised, let me just okay. I have to send a request for sharing screen. Okay, so let me go back to the so can you see it? It's fine.
Yeah.
So well, this goes back to the actually roots of the idea. Maybe I don't need to go to the roots of the idea yet, but I can actually give you the whole chronology at the end, no suspense, so you can see how it goes. It was submitted to Science just with Sebastian in 2007, rejected after review. Then it was, and there's interesting stories around these actually. It was rejected because it was judged to be too similar to a paper that I submitted that I had published in Science in 2004 on something called the Bayesian truth theorem, which is BTS, which is just like your BTS, which is just like the Korean band BTS. So BTSs are all over the place, right? Then we sent it to Nature after a long delay with John McCoy. Okay, so that became quite a different paper because John was a starting PhD student at BCS, but pushed this in a different direction. We submitted it to Nature. We had a rejection with a very very hostile review, and that hostile review was an opening. So we resubmitted it, and the editor did accept the resubmission, kicked out that referee, and sent it out again, but it was rejected again. So that's the story. Then 2 years later, we sent it to Science, where it was desk rejected, and we complained, and it was again desk rejected. And then we sent it finally to Nature in 2016, where it was accepted. So that's just the history. There's a lot of stuff missing there, but that's the basic history. And you'll notice the title has changed. The title became much more technical. And the first submission to Science really didn't have any, it had almost no data. It had a tiny classroom study on the state's capitals and was essentially, mathematically, it was very derivative of my 2004 paper. And it was also much more mathematical. What happened over the course of the revisions is the paper became less and less mathematical because we finally understood that we actually had something very simple. And initially, it was really very technical and mathematical. And that's kind of one of the amazing realizations that when I started working with this, I started working with Sebastian Sung and Michael Kearns, who's a very mathematical computer scientist, physicist, and so on. And we were doing all kinds of they were doing all kinds of technical things. And then gradually became clear, once the three of us with John McCoy, that we didn't need this math. And Michael Kearns said, I don't need to be a part of this paper because, the math is not necessary. And so I remember one point even we said, well, here's the good news and the bad news. The good news is we don't need the math. The bad news is we don't need the math. And there is bad news because I did get someone complimenting me on a very nice review paper. So there's no equations, it has to be a review paper. So it's but there is some math independence. But basically that's the now if there's interest, I can tell you how we handle the rejections, because that was except for we never questioned the original decision, except in the 2015, we did question the desk rejection to science. We never questioned an original referee decision, editorial decision to reject. We basically waited, and we wrote a new paper that we felt could claim to be a new paper. And so what you see, basically three really here are very different papers, fundamentally different papers. If I go back, so the very first 2007 paper was very mathematical. It used equations that I had in 2004, entropies, all sorts of things. It all turned out in the end not to be necessary. Those equations, I have to say, came from my 2004 paper in Science, which interestingly, just to give you a sense of the spectrum of editorial decisions, that was sent to Science. It was accepted essentially with only one request to get rid of a paragraph and a figure, just went right through. No data, just theory. Okay. That dealt with incentives for honesty, truthfulness, and so on. And the second, whereas this paper dealt with truth, and that created a lot of confusion. The distinction between truthfulness and truth, it's very easy to confuse it. And so when we submitted it, 2007, people said this is a, when we submitted 2007, people said this is the same idea. And it had a lot of the same equations. Then we sent it to Nature. At Nature, our cover letter anticipated this problem. And we also kind of put in a tease. We said, hey, you people published something in 1907, you know, why not publish something again? You know, this is like, why not? And then we said, we note that to prevent any confusion, this is a letter to the editor. We emphasize the present paper deals with different problem involving different meaning of the word truth. It was rejected. I've used these quotes and often in talks. We illustrated this, our method saying, in principle, it might answer questions like, what's the probability that mankind will survive? What's the probability nuclear weapons might be used? And the referee said, this is just nonsense. This is like, the referee was clearly a physicist or something like that. You know, social scientists are just asking these ridiculous questions. They can't be a right answer. This is just speculation and so on. And this is the kind of referee that's your friend. This is my message. This is a referee that struggled, worked hard, just did not understand it. That is a good that is a person you can argue against. The bad referee is someone who basically doesn't want your paper published for some reason. Because that type of referee will have one complaint, you fix that complaint, we'll move to another complaint, and so on. This person was just frustrated, and the frustration led to. And so we addressed this referee, and we resubmitted it, and we said, but we didn't complain about the referee. We just said the paper is much shorter, just over half the length. And now it's a letter, not an article. So it's a new submission. It's not an article, which is a different category. It's now a letter, short. Okay. And it went out for review, and the editor actually apologized for the tone of the earlier referee. So it was very, very, very nice. But still, we didn't clear the hurdle. Science was just a closed door. It didn't want it. And then finally, we went to Nature again. But now we also had additional studies. We had art, we had lesions, we had these sort of real world studies. But we had to make an argument, how can you go 3 times to the same journal? And he said now that basically we said, formerly we had math, now we just have a simple verbal argument. And we said, anybody who is, a person without any math is positioned to apply the new voting method, basically. And so we said, now we'll make an argument that it's not too technical for Nature. And then we noted that we had the additional studies. Okay, so this is the pitch. So a huge amount of effort went into these letters. You know, we would spend a week on these letters. But we felt that we had a reasonable editor. If we didn't feel like we had a reasonable editor, it would be pointless. So each of these rounds, a lot of the effort went into the into crafting these letters. And these are just for credits. These are the 5 people and the 6 people. Before we close, I just want to make sure they're up there. So Michael Kearns is the computer scientist, mathematician, who was important early on, but his bag of tricks was basically not needed. You know, that we realized that. And then undergraduate at MIT did that. Very remarkable student selected the paintings, and then my wife Drazen Prelec and Murat Alam did the lesion study, so they were very important. And so this is the this is the team. And if there's any more questions, we're almost out of time. But I thought this would be interesting paper because of the history. But the 2 lessons are: don't argue rejection. If you want to go back to that journal, wait and send them a different paper, or go to a different journal. And I think the one issue I might second guess myself, why do we keep going back to the same journals? And I think we did that because we really felt it belonged in those journals, because it was a general interest. We thought this was legitimately a general interest result. So, but it very well might have, you know, not gone through.
Yeah. And I think also an important lesson is, you know, simplicity is hard to achieve. And I think seeing, right, like the evolution of the project, what you can, right?
Very hard.
Mm-hmm.
Very hard. It's just amazing. In retrospect, you feel kind of stupid. But when we started this, we were really circling with all sorts of mathematics. And that's because if you have a set of concepts or tools, mathematical tools and so on, you sort of go in that direction. And that's why it's good to have co-authors, because they might actually pull you in that. That's where John McCoy also helped greatly. So he was here from 2012 on, 2011 probably.
For the second time, yeah, should we take a couple of questions from the audience? If any?
Yeah, I think so. For the remainder of the questions, we'll post it on our website, and you can see how your response is compared to Drazen's response. But we can take some questions now.
It was super clear and really fascinating. Oh, we cannot hear you.
Can I go ahead and ask?
Yes.
Yes.
Yeah.
I'm interested in how you initially came up with this idea. The intuition is very clear, but you say you started mathematically, so.
Yes, it will take maybe 2 minutes. Is that okay? 2-3 minutes. So it goes back to the this paper, and I will tell you then what the problem is also. This was a paper that was focused on getting people to playing a game where they would predict each other, and they would get a score reward, and if they wanted to maximize the score, they should honestly reveal their private information. So this was what economists call a mechanism, Bayesian mechanism. And buried in that paper was a result that was completely unnecessary and accidental. It said that the person who gets the highest score in this game, and this game has nothing to do with truth, the person who gets the highest score in the game puts most probability on the distribution of answers of other people playing the game. So it's a person who puts the most probability on that distribution of answers. Now, if you believe that that distribution of answers which is the entire crowd's answers, is one-to-one related to the true answer, the truth, then that person starts to look like an expert because he puts highest probability on what is the true answer. So that means that you have a method in principle that can pick out one person in a crowd that puts highest probability on the true answer. That was the idea. But what we didn't know is how to find the true answer. We felt like we could find the person who's the expert, but that person might not think that the true answer is the most likely answer, you know. So that was the missing step. But roughly 10 years ago, or actually now 20, we're going back 20, this was 2004 to 2007, we had a notion we could find an expert, but we couldn't go from the expert to what the true answer was. So the roots go back to this kind of game theoretic idea where, and the common element is that in this paper, people were also predicting each other. But the reason they were predicting each other is because we wanted to have incentives for people to be honest, not because we're concerned about, and they could be honest about things, you know, their personal habits and things like that. That's the idea. And that created a problem in the first time we submitted it. We really traced it very much to the 2004 paper. And then we had this tactical issue in later versions. We're very, very scared that people would say, oh, this is just like that paper. So we actually moved much further away. And in fact, we didn't need that result. We didn't need any of the math from 2004 for this. So, but that's what got us thinking in this direction. I hope, yeah.
Kind of think
But
about
it's a little bit accidental. There's an accidental step that game had that property of picking out the expert was not what I was looking for, not what I needed. And it was in the paper, and I had trouble finding it myself yesterday, putting these slides together. It was like 4 lines in that paper that were just kind of nice property of this game that it finds an expert.
Yeah, it's super nice to see how the various pieces of the puzzle fit together, and yeah, being open to accidents, things unexpected.
Yeah, there's a lot of accidents.
Yes, exactly. It was super interesting. Thank you so much, Drazen, for sharing.
Yeah, it was a pleasure, and thank you for the invitation.
Yeah,
and I should say it's a great thing that you're doing, because a lot of this stuff just gets buried. People don't keep track, and in an ideal world, all of the referee comments would be at some point available for historical study.
could not agree more. Yeah. Well, thanks a lot. And yeah, let's keep the conversation going on the behind the scenes of our own research projects. Thanks a lot for your generosity and your time.
Thank you.
Thank you.
Bye-bye.